Hi everyone. Today's video we are going to discuss about points and crossings. So what is this points and crossings? Assume that you are driving and you have reached a junction and you want to turn in a particular direction. So according to the driver's will and wish, the vehicle can be turned in the direction he wants to move with the help of the steering wheel. But when coming on to the trains or when coming on to railway, so moving from one route to another route or deviating from one route to another, it's not that easy because of the speciality of the wheels of the trains. So when seeing the train wheels, you can see it has got two parts. One is the tread and another one is the flange. So because of these flanges that is being provided, the train cannot be easily turned from one path to another route. Therefore, it requires some special arrangement and that is made possible through points and crossings. And today's video, we will be discussing about what are these points and crossings and why we need to provide this, and also we will see the component parts of points and crossings. So welcome you all to my video.
Switches and crossings play an essential role in connecting the rail network. We use them to guide trains from one track to another and to enable lines to cross paths. Put simply, they're the junctions that allow us to create a multi-lined, multi-routed rail network. At Network Rail, we own over 20,000 switch and crossing units. They come in many different shapes and sizes, and all are made to measure for their specific location. To understand how switches and crossings work, we first got to look at the wheel-rail interaction. Train wheels move along the rails guided only by the pound coin-sized area of wheel that sits on the railhead. The wheel rim, or flange, doesn't normally touch the rail. Flanges are only a last resort to prevent the wheels becoming derailed. A switch can guide a wheel in one of two directions. A crossing creates a gap in the rail for the flange to pass through. This is a switch, also known as a point. It's the moving part of the switch and crossing layout and is made up of two long blades which can move across to guide the train one way or another. This is the switch rail, and this is called the toe. This is called the stock rail. It's a non-moving part of the switch. The two switch blades are fixed to each other by a stretcher bar to ensure that when one is against its stock rail, the other is fully clear and will provide room for the wheel flange to pass through cleanly. This is a crossing. It's the non-moving part of the switch and crossing layout that allows a train to pass in either direction once the switch has been set. This is the nose of the crossing. Either side of the crossing area, wing and check rails are provided to assist the guidance of the wheel sets through the crossing. Crossings can be either fabricated, made up of two machined rails joined together, or they can be cast as a single unit. Modern crossings are now cast from manganese steel, which is an advanced alloy that gets harder with use. This is an important property as the nose of the crossing can take high impact loads as train wheels pass through.
My name's Lawrence Walton and I'm a graduate engineer working for Network Rail. I'm here today to teach you about switches and crossings.
The most simple form of S&C is the turnout. This is a left-hand turnout. As you can see, it diverges from the main route in a leftward direction. This is how it works. In normal mode, the left-hand wheel rolls along the switch rail and there's flangeway clearance for the right wheel to continue along the stock rail. The inside surface of the right flange is kept on course by the check rail. This restrains the wheel set and ensures it is directed along the correct route. Meanwhile, the left wheel transfers contact between the different parts of the crossing. That's where there's a high impact load. In the reverse, the right wheel rolls over the switch rail and follows its geometry. The inside surface of the left flange is guided by the check, forcing it to follow the stock rail on the new route. And the right-hand wheel makes a crossing, again impacting a load on the crossing nose.
There are many different types of switch and crossing on the network. They include turnouts, diamonds, crossovers, and slip diamonds. The type we use is determined by a number of factors, including the number of lines involved, frequency of use, and running line speed. Trains travelling at high speeds need long switches and crossings. At low speeds, such as in stations, trains can make tighter turns. Train movements across the network are set and controlled by signallers, who use switches to set routes for trains. Switches can be propelled by various devices. One of the simplest forms is a ground frame setup, a series of rods and cams attached to levers in signal boxes. These are now largely being replaced by remotely operated hydraulic and electromechanical devices.
Seen by rail sides all across the country. This is an HW2.
Points and crossings are the special arrangement to divert the train. So here in this figure you can see a train from A. There are two possible options it has got. One, it can move straight to B, or it can turn its direction towards C. So this is made possible by means of points and crossings. So it provides flexibility in the movement by connecting one track to another. Thereby it enables the parallel movement, converging as well as diverging movements. But another important aspect is the safety aspect, because this becomes the weakest points over the track, and thereby they become susceptible to derailment at these places. So why points and crossings? Because of this special wheel arrangement, or because of this special wheel shape, the wheel has got flange, and in order to accommodate these flanges, special arrangements are required over the track, which are known as points and crossings. So let us see that in detail in the coming slides. The simplest combination of points and crossings, which enables one track, either a branch line or a siding, to take off from the main line, is what is known as a turnout. So the simplest combination of points and crossing is what is a turnout. There are two types of turnout basically. One is a right-hand turnout and another one is a left-hand turnout. And let's see on what basis are we deciding whether it is a right-hand or a left-hand turnout. So before explaining what is the difference between right-hand and left-hand turnout, we have to see these four basic definitions. So let's first see the facing direction and trailing direction, and I'll explain that with the help of this figure. So facing direction is, if a person is standing at the switch and if he is looking towards the crossing, then that becomes the facing direction. So the switch is the point from where the turnout start deviating, and crossing is the point where the two tracks are crossing each other. So you can see here two tracks. One is a main track and another one is a diverging track. So from here, from the switch, it starts deviating, and at the crossing, these two tracks cross each other. Okay. So if a person is standing at the switch and he is looking towards the crossing, and that direction is what is known as the facing direction. So what will be the trailing direction? If a person is standing at the crossing and if he is looking towards the switch, that becomes the trailing direction. When there is a facing point of turnout, are those where the train pass over the switch first and then it pass over the crossing. These are important to specify when the direction of movement of train is reserved for facing direction. And the next is trailing point of turnout, are those on the opposite side of facing point, in which the train pass over the crossing first and then over the switch. These are important to specify when the direction of movement of train is reserved for the trailing direction only. So from this facing direction, we can divide the turnouts into two, the right hand turnout and the left hand turnout. So in this figure you can see what type of turnout it is. Can you say? You are standing at the switch, you are looking towards the crossing, and here the track is deviating towards right, so it becomes a right hand turnout. Whereas if the same track is moving to the left hand side, then it becomes a left hand turnout. So that is how we can divide the turnout into right hand and left hand turnout. Hope this concept is clear to you. So let's see the component parts of the turnout. Basically, the turnout has got two parts. One is a switch and another is a crossing. So I'll explain that with the help of this illustration. So here you can see there is a moving part. This is the moving part, and there is the fixed part. And there are lead rails. So lead rails, they are the continuous rails. So here also you can see in the straight direction there is a lead rail. This one is a lead rail which is continuous. And here also you can see another lead rail. So the parts of the turnouts are attached to the lead rail so that the wheel, we will be enabling the wheel to turn its direction. So when coming out to the wheels, it has got two parts. Okay, the flange portion and the tread portion. So the tread portion will be directly running over the rail head, whereas the flange is the portion which guides the wheel. Okay, so this flange portion need to be accommodated by means of some special arrangement which is made possible through points and crossings. So let's see that. I told you it has got two parts. One is a switch part, which is the moving part. So this much portion can be called as a switch. So switch is the portion from where this turnout start deviating, or the branch line takes off from the main line from this switch. Whereas these two crosses each other or intersect each other at the crossing. So that is why it's given the name crossing. So mainly it has got two parts, the switch as well as the crossing part. So I can say this much portion comes under the switch, and this much portions mainly comes under the 6 and 7 comes under the crossing portion, and the 8, 9, 10 I told you these are the lead rails, and then there are operating system to control the movement of switches. Okay, so let's see that in detail. So you can hear from this illustration, you can tell in which direction it will be moving. So when there is gap between so this is the lead rail. Okay, so when there is gap between the lead and the tongue rail, the train will be moving to straight through movement. Whereas if there is gap between the right hand tongue rail as well as the lead rail, then the train will be turning towards right. So depending upon the gap that is there between the tongue rail or this the switch again has got different parts, the tongue rail. So here you can see this orange one, it is what is known as a tongue rail, which is a moving part. So this tongue rail sometimes may be attaching to the stop rail, or it will be moving away from the stop rail. So once it is attaching to one side of the stop rail, then there will be gap between the other tongue rail and the stop rail. So it will give a gap between them through which the flange can move. So if there is gap between them, then the train will be moving to the right hand side. Whereas if there is gap between the left hand tongue rail as well as the stop rail, then the train will be moving straight. Whereas in the crossing, there will be gap for the trains to move in both the directions. So actually the decision is made at the switch portion, and for that some kind of arrangement is required in order to facilitate this movement, which is made possible through some operating mechanism and which is known as a locking system. So all this we will see in detail in the coming slides. The points or switches, they are the moving part of a turnout, I told you already. So depending upon how these switches are moving, the direction of the train can be fixed. So it is the device used to divert the rolling stock from one route to another by switching the direction. So it essentially consists of a tongue and the stop rail. So the moving rail, here you can see in the figure, the orange one, the moving rail is known as the tongue rail. And the rail to which the tongue rails are attached, they are known as a stop rail. And this tongue rail again has got two parts. One is the heel portion, another one is the top portion. So the heel portion means one end of this tongue rail is firmly fixed to a heel block, and that portion is known as the heel portion. And there is a tapered tongue of this rail which is either being fixed to the either been attached, not I can say it is fixed, it is either it can be attached to the stock rail or it can move away from the stock rail. So here in this figure you can see the left hand trunk rail is being attached to the stock rail, where there is a gap between the right hand trunk rail as well as the stock rail. So if this is the case, the flash will be moving between this right hand trunk rail and the stock rail, and it will be diverted to the right hand side. So depending upon how this trunk rail is attached to the stock rail, the direction of the tail can be fixed. Okay, and the point. So in some textbooks you can see it like this, one side of this portion or one side of this is known as one switch, and this will be the second switch, and these two switches together is known as points. Okay, and the two switches or the two trunk rails are fixed to a stretcher bar or a switch rod, which decides in which direction the trunk rail should move, because the gap between the left hand trunk rail and the stock rail, similarly the gap between the right hand trunk rail and the stock rail should be the same, in order to enable the flash to move between this gap. So in order to make the movement to be uniform, these two are connected by means of a stretcher bar, and this is again connected to the switching motor, and there are different types of interlocking system by which we can decide the movement of this trunk rails. The stock rail, it is running a rail against which the tongues operate or the trunk rail operate. So here you can see there is a red rail, there is a blue rail, and there are green rails. Okay, so the red as well as the blue rails, they are the leading rails. Okay, they are continuous running rails to which the trunk operates. Okay, so top rails, they are the running rail against which the trunk operates, and here you can see the red one which is leading to the straight direction, whereas the blue one, they are leading to the left hand side. So this is an example of left hand turnout. How you are deciding the direction of the turnout? So if you are standing at the switch and looking towards the crossing, if the branch line is deviating to the left, it is an example of left hand turnout. So this figure is an example of left hand turnout. So here the leading rail, one is moving straight and the other one is moving to the left. So the stock rail is the one against which the trunk rail operates, and they are also known as the outer rail in the turnout, and the moving ones are known as the trunk rail. So that we will see in the next slide. So coming on to the trunk rail. So trunk rail, it is a tapered movable rail that lie between two stock rails. They are the moving part of the switch. It has got two portions, one is a toe and a heel, and the heel portion is attached to the heel block, and the other portion is the one which is moving with respect to the stock rail. So here you can see there is a gap between the stock rail and the left hand trunk rail, so that the train will be moving straight, whereas if there is a gap here, it will be moving towards right. It's an example of right hand turnout. Okay, so that is a trunk rail. So trunk rail, it is the tapered movable rail which lie between two stock rails. So here this and this is a trunk rail, whereas this is the lead rail leading towards right, and this is the lead rail that is leading to the straight direction. Okay. So this leading rails are known as the stock rails, and the trunk rails, they are operating between these two stock rails. It's made up of high carbon or manganese steel to withstand the wear and tear. The type of switches, there are two types basically. One is a stub switch and the split switch. So the basic difference between these two is, in the case of stub switch, it doesn't have a trunk rail. It doesn't have a separate trunk rail, and the main portion of the track is moving side to side to enable the direction of trains to deviate. Okay, so in the case of stub switch, in this type of switch, now separate trunk rails are provided, and some portion of the track is moved from side to side. It's an old form of design, and it's very rare nowadays. So now split switch is a common type of switch you can see, which is universally accepted or adopted one, where it has got different parts, or the entire the turnout is being split into different sections, like there will be a tongue section, there will be a stock rail, there will be a heel block, then there will be crossing. So since it is split into different sections, it's called by the name split switch, and this is a modern type of arrangement. We will discuss a different shape of switch. First one is the undercut switch. So undercut switch, in the case the height of the stock and tongue rail is same, it is desirable to cut out a portion of the flange at the foot of the stock rail so that the toe of the tongue rail is accommodated under the head of the stock rail. So such switches are termed as undercut switch. So it is a very old type of design and later modified to give way to the next type of switches. So let's discuss that. The next type is a straight cut switch, where the tongue rail is cut straight in line with the stock rail and hence termed as straight cut switch. So this is done to increase the thickness of toe of tongue rail, which as a result increases its strength. So it is much stronger than the previous one. And another peculiarity is this type of switch is suitable for bull-headed rails. So next is the overriding. So the figure explains the overriding switch, where you can see it is mainly adopted for flat-footed rail. So this is the common type of switch that you can see nowadays, where it has got a separate rail section of stock rail and tongue rails are adopted. The stock rail of heavy section and tongue rail of light section are used instead of cutting the flange rather than weakening the stock rail as in the case of undercut switch. The tongue rail in this type rides over the flange of the stock rail. Such switches are termed as overriding switch. Design is superior and it's more economical. Only the tongue rail portion is manufactured separately. Next is the stretcher bar. The toe of both the tongue rails are connected together by means of stretcher bars so that each tongue moves through the same distance or gap while changing the points. Generally, 2 or 3 bars are used near and behind the toe. The length of the bar is such that the distance between the two toes is equal to the gauge minus throw of the switch. So the gap between the tongue rail as well as the stock rail is what is known as the throw. So the length of what will be the length of the stretcher bar? It will be the gauge minus the throw. So generally 2 or 3 bars are attached near the toe. So this is a Greylick train crash which caused due to the defective point, and later when they inquired that, they found like the train was travelling at a speed of 153 km per hour, and these stretcher bars were missing, which led to this accident. So after the investigation, they found like the main reason was the stretcher bar was missing. At least there should be 3 stretcher bars, of which 2 were in damaged condition and the middle one was missing, which led to this accident because the train was moving at very high speed, say at more than 150 km per hour it was moving. So that led to this accident. And later the Network Rail, who is the owner and who is the operator of the rail networks in Great Britain, they were fined with an amount of £41 million. The sliding plate or the sliding chair, these are the special plates which are provided under the stock and tongue rail. These are essential because the tongue rail have to move towards or away from the stock rail easily. On these sliding plates, the stock rail remain fixed while the tongue rails are able to slide. So the chairs are 12.5 cm to 15 cm wide and of length increasing gradually towards the heel. The next, the throw of the switch. It is a gap between the tongue and the stock rail, and it is being fixed as 9.5 cm for broad gauge and 8.9 cm for meter gauge tracks. Next is the heel block or the distance block. These blocks are inserted between the heel of the tongue rail and the stock rail. These are made of cast iron and are used to provide a clear gap for the wheel flange. That's to maintain proper heel divergence. The distance block is same as the heel block but is used to provide a distance or gap for the flange way between the running rail and the check rail, hence termed as a distance block. Next is the crossing. Crossing is the fixed part of the turnout. I told you already, right? The switch is a moving part and the crossing is the fixed part, where there are arrangement of rails introduced at the junction where 2 rails cross to permit the wheel flange of a railway vehicle to pass from one track to another. It's a fixed part. So let's see the details of this crossing. What are the different components of this crossing? The crossing mainly has got a nose, and then it has got splice rails, it has got wing rails, then there will be guard rails. So we will see all these in details. The component parts include the crossing or a V-piece, then there is point and splice rail, there is wing rail and check rail. So let's see the component parts of a crossing. So essentially the crossing has got a nose. You can see here this pointed edge. It is what is known as the nose. So this nose is formed by two rails, and these two rails are known as the splice rail or the point rail. So the splice rail or point rail, they are joined together to form the nose. So depending upon how these are joined together, it can be called as a splice rail or a point rail, depending upon how the nose is formed. So I'll discuss that later. The next is the wing rail. So the wing rail, they are bent at the ends. On one end of the wing rail is connected to the lead rail. You can see the one end is connected to the lead rail, whereas the other end is flared, and this flaring is done to facilitate the entry of the flange wheel to this gap. So this flaring is done so that the flange wheel, the flange of the wheel can directly move through this gap. So that is basically the crossing is all about. So this is another figure explaining the crossing nose as well as a wing rail. So this nose is formed by this splice rail or point rail. So how this is being connected at the end, it can be called as a splice or a point rail. So basically you can say this to be the splice rail and this to be the wing rail which flares at the crossing. Okay, so this flaring will enable the flange to move smoothly between the two rail sections of the crossing. So let me explain to you the difference between the splice rail and point rail. So splice rail or point rail, they are the two rails that are joined together to form the nose of crossing. And there are two rails running by the side of that which will enable the flange to move between the crossings or between the two rail sections. They are known as the wing rail. So these two are known as the wing rail, and the rail sections that are joined together to form the nose of crossing, they are known as the splice rail or the point rail. So what's the difference between that? So the two rail sections can be joined together or machined together to form a crossing. So there are two ways of joining together. One is to the point rail, the splice rail can be attached. So point rail is the one which forms a pointed end at the nose. So this becomes a point rail to which another rail is attached, which becomes a splice rail. Whereas in the second arrangement, you can see both these rails become the point rail because these two forms a joint at the center which creates this nose of crossing. So these two are known as the point rail in the case of second arrangement. Then there's another figure explaining the different elements of a crossing. Here again you can see I've written here two things. One is TNC and ANC. That is theoretical nose of crossing, and another one is the actual nose of crossing. So what's the difference between this actual nose of crossing and the theoretical nose of crossing? So the point rail is never manufactured to a well-defined sharp point, as it would break off under the dynamic action of moving load. So a blunt nose is provided for the point rail. The thickness of the blunt nose is usually equal to the thickness of the web of the rail. So it is not always made pointed, it is kind of blunt at the nose. But for the calculation, we consider an imaginary sharp point. Okay? So the imaginary sharp point where the two gauge faces meet is known as a theoretical nose of crossing. So all the calculations are made from the theoretical or true nose of crossing. So that's the difference between theoretical nose of crossing and the actual nose of crossing. Actual nose is not actually sharp one, it is a blunt one, whereas theoretical nose of crossing, it is an imaginary point with respect to which all the calculations are being done. I already explained to you the different components of a crossing. Let me give you the definition of each of this. First is the wing rail. Wing rail, it converges to form the throat and diverge again on either side of the nose. So here in this figure, the yellow one is known as the wing rail. It's flared at end to facilitate the entry and exit of flange wheel in the gaps. The next is the splice rail. So here in this figure you can see the point rail as well as splice rail. Depending upon how these two are connected, it can be 2 point rails or it can be 1 point rail to which a splice rail can be attached. So splice rail, they join to form the nose of crossing. So here in this figure, it is separate point rail and splice rail. So the red one here, it is a point rail, and the blue one is a splice rail. So they join to form the nose of crossing. There is two nose of crossing. One is a theoretical nose of crossing, which is the imaginary sharp point with respect to which we are doing the calculations, and there is another one which is the actual nose of crossing, which is the toe of blunt nose, which is actual point of crossing. Then there is check or guard rail. So in the figure you can see the white ones, they are the check rail or the guard rail. They have provided they provide a path for the weak flange and they guide them in a proper direction. So a pair of check rails will be provided at the crossing. So it will prevent the sideways movement and saves the hitting of the nose. So when it crosses from it crosses from main track to the branch line, there are chances that the wheel will come and hit over the nose. So this can be prevented by providing the check rails at the crossing. So these are the different components of crossing. So there are different types of crossing. So depending upon how the angle is formed between the two rail section, based on the angle of intersection of the approaching rails, there can be acute angle or there can be obtuse angle or diamond crossing, or there can be square crossing. So this figure explains the diamond crossing as well as the square crossing. The first one is the diamond crossing, where the two turnouts are meeting at the center point. It becomes a diamond crossing. The other one is the square crossing. So sleepers at points and crossings. There are two methods of arranging the sleeper. One is the through sleeper type and another one is the interlaced sleepers. In the case of true sleeper, you can see for the straight section as well as the curved section at the point and crossing, you can see only a single sleeper being there for both the straight portion as well as the curved portion. So these are known as the through sleepers. So through sleepers, they have the advantage of maintaining the two tracks on the same level. But the problem associated with this is it requires longer sleepers, which are difficult to procure and transport. The next type is the interlaced sleeper. So in the case of interlaced sleeper, you can see there are two separate set of sleepers available for the straight portion as well as the curved portion. So the difficulty with this is, since too many sleepers are there, they will be placed at closer gaps. So because of which the packing of bellas between them become difficult. So it is it's difficult to maintain. And another problem associated with the interlaced sleeper is that it deforms easily than that of the through sleeper. So the curved track often deforms, which is highly undesirable at points and crossings. Therefore, if through sleepers are available, then that are preferred over the interlaced sleepers. So that is regarding the sleepers provided at points and crossings. So you can see here this is a right hand turnout and this one is an example of left hand turnout. Hope the difference between that is clear to you, what is a right hand turnout and a left hand turnout. So if you are standing at the switch portion or the point portion and then you are looking towards the crossing, if the branch line is deviating towards right, then it becomes the right hand turnout. Whereas in the case of left hand turnout, if you are standing at the switch portion and looking towards the crossing, if it is deviating to the left, it is the left hand turnout. So depending upon what is being asked in the question, sometimes you will be asked to draw a right hand turnout or sometimes you may be asked to draw the left hand turnout. So you have to draw it accordingly. Okay? So you must know the difference between right hand and left hand turnout. So simply with this figure I explain what's the difference between that. So sleepers, there are two types. One is a through sleeper, another one is a interlaced sleeper.